All right, guys, welcome. This is 2.1 and 2.2, the definition of the derivative. All right, so today is all about finding the derivative the long way. Yes, I know, it's exciting. And then after the first test, we can show you the derivative the short way, right? We have to earn it. Okay, so here we start with the page full of definitions, everything about what the derivative is, right? And if we get started here, the definition of the derivative of a function f at a number x, denoted by f prime of x, is given by f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now something must look really familiar here, right? This part is just the difference quotient. This is the difference quotient function. That's the difference quotient. And the derivative, all the derivative is taking the limit as h approaches 0 of the difference quotient. So we are used to doing the difference quotient by now. The one thing we haven't done is, well, actually we have based on some examples in what, 1.4, right? Is plug in 0 for h. So our whole goal is to get rid of this h so we can plug in that 0. That's it, right? That's what we want to do. All right. And this happens if the limit exists. And f prime of x is read as f prime of x. These are the notations. Y prime, this is y prime. This is dy over dx and d over dx. These last two notations are called Leibniz notation. They mean the same thing, take the derivative. So the first one, dy over dx, says take the derivative of y with respect to x. The second one, d over dx, this one just says take the derivative with respect to x. That's it. So if you see those notations, y prime, dy over dx, d over dx, f prime of x, they all mean one thing, take the derivative, okay? Take the derivative. Okay. All right. And I think we'll get into more of it later on this section, but what the derivative does, derivative is just a fancy word for slope, right? Derivative is just a fancy word for slope. The derivative tells us at what x value the original function is increasing or decreasing. That's what it does. The derivative finds the slope of the original function at a given value of x, at one given value of x. So that's what the derivative does. It finds the slope at one given point of the original function. Okay. Maybe we don't have to get into it more. That's what the derivative is. That's what the derivative does. Okay. Definition of a differentiable function. A function f is differentiable at x if the derivative exists. It is differentiable on an open interval AB if it is differentiable at every number in the interval. Also, f is differentiable at x, then f is continuous at x. So basically, to have a derivative, you must be a continuous function. You must be continuous on some open interval. That is how you take a derivative. That function must be continuous. Okay. And guess what? If you don't have a derivative, this means that your function is discontinuous. Ah, so easy, right? So the non-existence of a derivative. A function is non-differentiable if the graph of f has a hole or break in it, then the derivative does not exist. That means picture 1, right? Has a hole and a break. B, the graph of f has a sharp corner at x, then the derivative does not exist, and the graph has no tangent line at x. All right, so sharp corner, right? We have a sharp corner there. And C, the graph of f has a vertical tangent line at x, then f prime of x does not exist. So if you have a vertical tangent, then the derivative does not exist. So these graphs, all four of these graphs are examples of a function whose derivative does not exist. Okay. All right, so moving on, now we have the definition of a derivative, and now we are going to practice on how to find a derivative. I'll do it step by step. That is just the way I work it. If you want to do it in one go, you can as well. So basically, we're going to find the derivative using the definition, which is above on the first page. So find the derivative, and we will use the definition. The limit as h approaches 0 of f of x plus h minus f of x over h. Nothing new here. The only thing new is the limit part. That's it. And of course, some notations, right? So we're doing it on x cubed minus x. So like I like to say, step A, or step 1. What is f of x plus h? What is f of x plus h? This means take x plus h and plug it in for every x into the original function. All right. So this means that we will have x plus h cubed minus x plus h. Now all we have to do is expand. I'll have x plus h times x plus h times x plus h minus x minus h. And then distribute, distribute, distribute. And I think we've distributed this enough. Ooh, I don't want to make a mistake though, right? So here, I'll just do it anyways, and then we can save it, because this would be x squared plus 2hx plus h squared minus x minus h. And then if I distribute that out, I'll have x cubed plus, and then I'll have 2hx squared, which means I'll get 3hx squared, and then I'll have xh squared. So this means I'll get 3h squared x. And then after the final thing, I'll have plus h cubed minus x minus h. All right. So I did skip a little step in there, but we should be comfortable by now foiling all of that out. Okay. And that ends step A. And normally in step A, there is nothing we can do here. We cannot combine any like terms at the very end. So we move on to step B. Step B, what is f of x plus h minus f of x? Well, did we find f of x plus h? Yes, we did. All of this is f of x plus h, so just bring it down. So I'll have x cubed plus 3hx squared plus 3h squared x plus h cubed minus x minus h. So remember, all of this is f of x plus h. And then we're going to subtract the original function. But make sure you put it in parentheses. So we're going to subtract the original function. X cubed minus x. That's it. And this is f of x. Okay. Distribute the negative, and let's simplify. x cubed plus 3hx squared plus 3h squared x plus h cubed minus x minus h minus x cubed minus x. Okay? Now we see that after we distribute the negative, we'll have some terms that cancel. X cubed and x cubed, gone, gone. Oh yeah, see? And don't mess up your signs. This should be positive. And then negative x, positive x, cancel, cancel. Okay, so here is what we are left with. 3hx squared plus 3h squared x plus h cubed minus h. And now what I like to do on the second step, the final step, is factor out the common factor of h. I get 3x squared plus 3hx plus h squared minus 1. And that ends step B. Now let's move on to step C. Let's put it all together. Step C. We want the limit as h approaches 0 of f of x plus h minus f of x all over h. Just put equals right now. Well, we know what f of x plus h is minus f of x is. That is all, oops. That is all of this. So we just bring it down. So you'll have the limit as h approaches 0 of h times 3x squared plus 3hx plus h squared minus 1 all over h. And like butter, these h's will cancel. Does that make sense? Probably not. All right. And now what we are left with is the limit as h approaches 0 of 3x squared, 3hx plus h squared minus 1. And now all we have to do is plug in 0 for h. This h becomes a 0. This h becomes a 0. And all we are left with is 3x squared minus 1. And now let's state it as the derivative. We are going to say, for our final answer, f prime of x, the derivative, is 3x squared minus 1. There we go. Awesome. All right. It's definitely a process, and it's very easy to make a mistake, as I did distributing that negative. So watch every single step you do. Watch when you distribute the negative. Watch all of that. If you mess up one negative, this whole thing is done. It's done for, and you got to start over. All right. Well, you don't have to start over. You can trace back to where you think you made the mistake. Okay. All right. So what we found is the derivative. And the derivative, 3x squared minus 1, can find the slope for the original function x cubed minus x at any given value of x. So here, let me just draw a quick sketch of what I'm talking about. So x cubed minus x, if you take an x out, that'd be x times x squared minus 1, right? Which means you'd have an x-intercept at 0. So we'd have something at 0, 1, and -1. And it's a positive cube function, so our graph would look something like this. Okay, so what this is saying is that, well, the derivative of 3x squared minus 1 can find the slope at any given point, right? So let's say, so this is 1, this is 0, this is, oh, that's -1, and this is 1. Oh, hang on. Let's say that when x is 2, we want to know the exact slope at this point, right? We want to know the exact slope at this point. And all we have to do is plug in 2 to the derivative. So I would say f prime of 2 equal to, what was our derivative? 3x squared minus 1. All right, which means that we would get 3 times 2x squared minus 1, or 2 squared minus 1, which would give me 3 times 4 minus 1, which would give me 12 minus 1, which would give me 11. This means that at exactly 2, when x equals 2, this slope is 11. So right at that x value, your y values are increasing at a rate of 11. Your slope is increasing at a rate of 11. All right, so that's all it does. Maybe let's try another example, right? Of course, if my graph is correct. I'm pretty sure the graph is correct. When I say pretty sure, right? Let's say that our next value is 0.5. Let's get closer because it's decreasing. So let me see. Well, I'll do the calculation first. Let me see if 0.5 works. 3x squared minus 1. 0.5. Okay, good. Yes, 0.5 will work. So let's say we have 0.5 here. And this means we want to find the slope at this point. Well, this means that if you look at the graph, based on my graph, it looks like our graph is decreasing, right? So this is decreasing and this is increasing, right? So if I plug in 0.5, instead of getting something positive, I should get something negative. So let's try that out. If I say f prime of 0.5, I'll get 3 times 0.5 squared minus 1, which gives me 3 times, what's that, 1/2 squared, that's 1/4. So that would be 0.25 minus 1, and I would get 0.75 minus 1, which would give me negative 0.25. So this means that exactly at exactly at this x value of 0.5, your slope will be decreasing at a rate of negative 0.25. So all this derivative does is find the slope at exactly one given value of x for the original function. That's it. That's pretty cool, right? Which means you can do it for any values on this function. Pick an x value and you will see, okay? All right, so that is just an example of what's going on. Okay. Other than that, finding the derivative using the definition is purely algebraic. We are substituting in, we are expanding, we are foiling, we are distributing, we are canceling like terms, all that good stuff. The only calculus we use on it is when we apply that limit. That is it. Crazy, I know. All right, 2. Find the derivative of y equals 2x plus 1 over x plus 2. Oof, it's a fraction. I know. Okay, so step by step. We'll start with f of x plus h. That's as big as I can go there. Okay, perfect. A, f, come on. F of x plus h, and we'll get 2 times x plus h plus 1 over x plus h plus 2. Okay. Clean it up. Distribute the 2. We get, I'll just say 2x plus 2h plus 1 over x plus h plus 2. Done. That is step A. We can't go anywhere else. We can't do anything. So it's done. Okay, now we move on to step B. Subtract the original function. All right. So B. F of x plus h minus f of x. All right. Bring down f of x plus h, which was 2x plus 2h plus 1 over x plus h plus 2 minus the original function of 2x plus 1 over x plus 2. Okay, so like I said, you can put in parentheses. This one you don't really have to, because there's something we have to do here. We want to combine the two fractions, and we know to combine two fractions you need a common denominator, which means you look at the denominator of x plus h plus 2 and x plus 2, and they have nothing in common. If you think that h is common and you just say, hey, this needs to be multiplied by h over h, that is incorrect. Because if you do that, this becomes h times x plus 2, which is definitely not the same as x plus h plus 2. So just know that x plus h plus 2 and x plus 2 have nothing in common. So when you have nothing in common, well, you multiply the fraction on the right by the denominator on the left, and you multiply the fraction on the left by the denominator on the right, which means the right fraction I'll multiply by x plus h plus 2 over x plus h plus 2. The fraction on the left I multiply by x plus 2 over x plus 2. Okay, and now let's do the math. We'll get x plus 2 times 2x plus 2h plus 1 minus, now I'll bring in my parentheses, 2x plus 1 times x plus h plus 2. All over x plus 2 times x plus h plus 2. Ooh, yay, fun, right? Now, we're going to do lots of distributing in the numerator. Okay. So first one will give me 2x squared plus 2hx plus x plus 4x plus 4h plus 2 minus, keep the parentheses there, and you'll get 2x squared plus 2h x, 2x squared plus 2hx plus 4x plus x plus h plus 2. Oh, that's a lot, right? All over the same denominator. Look at all those terms. All over x plus 2 times x plus h plus 2. Okay, distribute the negative. Actually, can we combine terms and distribute the negative at the same time? That'll save us some space. So on the left side, no 2x squared, so there'll be a 2x squared there, plus I have a 2hx by itself, so 2hx, and then x and 4x give me 5x plus 4h plus 2 minus, and now I'll distribute that negative, 2x squared minus 2hx, again, 4x and x give me 5x, that'll be minus 5x minus h minus 2 over x plus 2 times x plus h plus 2. All right, cancel time. All right, 2x squareds are gone, 5x's are gone, 2's are gone, and I think that's it, right? Yeah. Actually, no, one more, right? 2hx and negative 2hx. And all we have left is 4h minus h. Oh, wow. Just make sure I didn't miss any terms, right? No, so we're left with 3h. Hey, that cleaned up nicely. So we're left with 3h over x plus 2 times x plus h plus 2. And that is the end of step B. Whoa. Now we go on to step C. What is the limit as h approaches 0 of f of x plus h minus f of x over h? All right, well, we know all of that. The limit as h approaches 0 of 3h over x plus 2 times x plus h plus 2 all over h. And then I'll allow it. This h, that h, cancel. And we get the limit as h approaches 0 of 3 over x plus 2 times x plus h plus 2, where it is now safe to plug in 0. And the only thing that becomes 0 here is this h. So we get left with 3 over x plus 2 times x plus 2, or 3 over x plus 2 squared. There it is. Ooh, that was good. Now we could actually state the answer as the derivative. I mean, it is the derivative, but with the proper notation. We can say y prime is equal to 3 over x plus 2 squared. Oh, buddy, look at that. Okay, awesome. So it would be, yeah. We're good, unless I messed up a sign somewhere, but I don't think so. Let me check my work really fast. Uh, 2x plus 1. X plus 2. Three over x plus 2 squared. We're good. Okay, awesome. More coffee, more energy. All right. So here we get to the definition of the tangent line. So the tangent line is a line that touches a curve at one point. What does the derivative do at one point? It finds the slope at one point, right? The slope of the tangent line at a given point on a curve is also the slope of the curve at the given point. Just what I said, right? All right. So this means if you make the connection, the slope of the tangent line must also be the derivative, because the derivative finds the slope at exactly one point. Therefore, you will use the same formula to find the slope of the tangent line. Look at this. The slope of the tangent line is the same as y2 minus y1 over x2 minus x1, which is the slope formula we learned in elementary school, right? And then that translates into f of x plus h minus f of x over x plus h minus x, which then translates into the limit of the difference quotient function, the limit as h approaches 0 of f of x plus h minus f of x over h. What we've been doing all day today, right? And we know that this is also the definition of the derivative. So if you're finding the derivative and you plug in a number for x, you're also finding the slope of the tangent line, right? Okay, which means that we can also relate this to instantaneous velocity. So average velocity is displacement over time, which is also equivalent to the limit of the difference quotient function. Because if we're looking for instantaneous velocity, that means we're looking for velocity at one exact point. And if we're looking for velocity at one exact point, we're looking for a rate of change. We're looking for a slope at one exact point, which means we're also finding the derivative. You see, it has multiple meanings, but the equation, the formula does not change. Okay, excellent. All right, and the instantaneous velocity was kind of like those problems you did in 1.4, where you did the average velocity formula, velocity of time 2 minus velocity of time 1 over time 2 minus time 1. And as it said, as it gave you the time, like 2.5, 2.1, 2.001, the final question was, what do you think the average velocity, the instantaneous velocity would be at 2? So that's what the derivative does. The derivative could have made that answer so much faster. So that's what we're doing here. All right. So let's go ahead and find the equation of the tangent line. Okay. So now we're going to take the derivative. Then with the derivative, we're going to find the slope of the tangent line. And then with the slope of the tangent line and a given point, we can find the equation of a line. So you only need 2 ingredients to find the equation of a line. The ingredients are, you need a slope and you need a point. You need a slope and you need a point. Those are the only 2 ingredients you need to find the equation of a line. Any line. Doesn't even have to be the tangent line. That's just to find the equation of any line. Okay, so let's try it out. Three, find the derivative of the function f of x equals x squared minus 8x plus 9. Then find the equation of the tangent line that passes through the point 3, -6. All right, excellent. So first thing we're going to do is find the derivative, because we know the derivative is also the equation of the gives you the slope of the tangent line. It is the same exact formula that we use. We use the definition of the derivative. And then with that, we are going to find the equation of the tangent line. I'll go through all of that. First up, the process. Let's find the derivative using the definition. So let's see. All right. So we can do it step by step by step, but let me show you what it looks like in one go ahead, right? Whew, this should be exciting. All right. So we'll just call this A. We'll say find f prime of x, which is also the slope of the tangent line, right? Okay, so we're going to say f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Like I said, this is one go ahead, right? I get the limit as h approaches 0 of x plus h squared minus 8 times x plus h plus 9, right? All of this is f of x plus h minus the original function, x squared minus 8x plus 9 all over h. There's f of x. Okay. Now, let's simplify it. Where should I go? Let me see what room I'm working with here. Oh, I got a lot of room. So I'll just go down. I can't go to the right. Okay. You get the limit as h approaches 0 of x squared plus 2hx plus h squared minus 8x minus 8h plus 9 minus x squared plus 8x minus 9 all over h. And then the limit as h approaches 0, and x squared is gone, 8x is gone, 9 is gone, and we are left with 2hx plus h squared minus 8h all over h. And then factor out that h. So you get the limit as h approaches 0 of h times 2x plus h minus 8 all over h. Cancel, cancel. Almost there. The limit as h approaches 0 of 2x plus h minus 8. Plug in 0 for h, and we get our answer, 2x minus 8. This is the derivative, and this is also the formula or the equation for the slope of the tangent line. Okay, so I'll go to step B. All right, but we can say that this is, yeah, let me go back. This is f prime of x and or the equation to find the slope of any tangent line at any given value of x. So then we're going to go to step B and say find the slope. All right. So B. Find M tangent. And we know that M tangent is given by 2x minus 8, right? M tangent is given by 2x minus 8. Well, are we given an x value to plug in? Look at the problem, and we're given a point. We're given a point of 3, negative 6. 3, comma, negative 6. Which one is the x value? And if you guessed it, 3 is the x value, right? So you're going to plug 3 into the tangent, slope of the tangent equation, and that'll give us the slope of the tangent line at exactly that point of 3, negative 6. So that's what we're going to do. Plug in 3. I'll say so this means that M tangent is going to be 2 times 3 minus 8. And this is going to be equal to 6 minus 8, which is negative 2. This is our slope. That is the slope of the tangent line at 3, negative 6. Now we move on to step C, which means find the equation of the tangent line. Okay, so the 2 ingredients you need. I said it before, you need a point and you need a slope. They give us a point of 3, negative 6. We found the slope, which is above, of negative 2. Our slope is negative 2. Those are the 2 ingredients we need, point and a slope. Let me make sure that point was correct. 3, negative 6. Okay. All right. So we're going to find the equation of a line. And a line we know is y equals mx plus b, right? A linear function. So what I'm going to introduce is my favorite formula, the point slope formula. So this is and this formula helps us find the equation of any line given a point and a slope. It's in the name of the formula, point slope formula. That's all you need. So for point slope formula, it is given as y minus y1 equal to m, the slope, times x minus x1, where you need a y value and an x value to plug in for x1 and y1, and you need a slope to plug in. We have all of those right above it. Let's plug them in. So 3 is my x1 value, 6 is my y1 value, 2 is my slope, right? So let's plug them in and see what happens. We will get y minus y1, which is negative 6, equal to my slope of negative 2, times x minus x1, which is 3. Now, all we have to do is solve for y. Y plus 6 equals negative 2x plus 6. Move the 6 over, and we'll get y equals negative 2x. This is the equation of our tangent line. Okay. And now we'll probably want some graphical representation just to show what we did, other than just crunching numbers, doing a bunch of algebra. Who knows what it means, right? Who knows what it means? All right. Let's see, 2x minus 8, just making sure my numbers are right. 6 minus 8, negative 2. Okay. So if we were to graph this, x squared minus 8x plus 9 would have an x-intercept at what? 9 and 1? It would be x minus 9 and negative 1. So I'd have something here at negative 1, something here at 9. I don't have to go that far. Let's just say this is 9. And my function would look like this. All right. So what we're saying is that at the point 3, negative 6, so 3, negative 6, which is probably around here, we'll say this is 3, and somewhere around here, we'll say is negative 6, right? So we're looking at this exact point. So what we're saying is, based on the derivative, we found the slope at this exact point to be negative 2. I'm sure my graph is off a little bit. I'll throw it up on Desmos just to do a better graph. So what we're saying is that the slope at this point is negative 2. And since we have this point and we have a slope, we can find the equation of the tangent line. And that happens to be, well, remember the tangent line will come, share one point, and take off, right? That's what it does. So since we have a point and we have a slope, this means that my tangent line would look something like this. Where this equation would be y equals negative 2x. And that's it. That's everything we just found. Using the definition of the derivative, plugging an x value in to find the slope, and then using algebra, well, we've been using algebra the whole time, but an algebraic point slope equation to find the linear tangent line. Okay. Like I said, let me throw this on Desmos. So give me one moment. Let me see. Let me do this. Go here. Go there. Desmos. And it was x squared minus 8x plus 9. Oh, I was totally wrong about the x-intercepts. Oh well. It's not definitely not factorable enough, clean enough to get proper x-intercepts. So yeah, my graph is definitely off. Okay, so let me show this screen. Let's go back to Zoom. I'm gonna say stop share on here. You look at me now. Let's go to Desmos. Let's see. Here we go. Okay, so you guys should be seeing this now. This is the graph of x squared minus 8x plus 9. I'm gonna plot the point 3, negative 6, which you see it just created down there. And what we did was find the slope at this exact point. I wonder if it can do that. I don't know. I don't know Desmos that well enough to do it. Okay. So the next thing we found was that our tangent line was y equals negative 2x. So y equals negative 2x. And look at that. Almost like my graph, this one's just definitely more correct, right? Okay, so if we look, we see the green line is our tangent line. We come down, we share one point with our function, 3, negative 6, and we take off. Crazy, right? So we did all the math just to find that. Okay, and that's everything we're doing. That is a graphical representation of what we have just done with the use of the derivative and the point slope formula. Okay. Could I play around with this more? Let's move on because I think we have one problem left. But Desmos is cool, so probably could find the slope at that point. But who knows? All right. What are some fun options here? Add an item, table, folder, image, settings. Nope. Okay. One day I'll figure it out. Let's move back to the notes. Okay. All right. We reach the very last problem. Find an equation of the tangent line to the function y equals the square root of x at the point 1, 1. Okay, here we go. Let's use the definition of the derivative. So again, I'll do this in one go. So we'll say A find y prime, the derivative. So y prime is going to be the limit as h approaches 0. And now you're going to have the square root of x plus h minus the square root of x all over h. And again, this is f of x plus h, and this is f of x. Hey, that was easy. But now, what do we do? Because we have f of x plus h, and we have f of x. It's all over h. Now we need to get rid of the h in the denominator. And we are going to multiply by something special. It's something we've been doing a lot lately. We're going to multiply by the conjugate. We're going to conjugate this numerator. So let's do that. So let's multiply by the conjugate, which is square root of x plus h plus the square root of x over square root of x plus h plus the square root of x. Okay, and now FOIL. This becomes the limit as h approaches 0. If I FOIL the top, I'll get x plus h, no middle term, and then minus x over h times the square root of x plus h plus square root of x. Okay, clean up again. And we'll get the limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x, where my h's will cancel. Up here, your x is canceled too. Okay. And what we are left with is the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x, where it is now safe to plug in 0 for h, which leaves us with 1 over square root x plus square root x, which becomes 1 over 2 square root x. There it is. There's our derivative. Can you leave it like that? If you want to. I figure we did so much work already. Leave it like that. If you hate seeing it like that, rationalize it, right? Does not matter. You want to rationalize it. If you rationalize it, you'll get what? Square root x over, what? 2x, something like that. All right. Okay, but there's no need to. All right. Which means now, let's find the slope of the tangent line. We were given an x value. We're given a 0.11, and the x value is 1. So lucky us, right? So B, find M tangent when x is 1, and M tangent is going to be 1 over 2 times the square root of 1, which is just 1/2. There's our slope. All right, cool. We are on our way. All right. C. Find the equation of the tangent line. All right. Well, we're given the point, 1, 1. We're given the slope, 1/2. Plug them into the point slope formula. Y minus y1 equal to m times x minus x1. And we're on the way home. Y minus 1 equal to 1/2 times x minus 1. Distribute. Y minus 1 equals 1/2 x minus 1/2. Add the 1 over, and we'll get y equals 1/2 x plus 1/2. There's the tangent line. Beautiful. All right. graphical representation, like I said, I'll just sketch it again really fast. Square root of x looks like this, right? And our tangent line happens at 1, 1. So here is 1, there's 1. So right about here, we know the slope is 1/2. And our tangent line, which is 1/2 x plus 1/2, would go through our point and take off. And that's it, guys. All right, let me do this. I'll just show another graphical representation, right? Even though that was my sketch, let's look at it correctly. Let's see. Close, close, close. Y equals the square root of x. Okay. And then we get the point 1, 1. And then we have our tangent line of 0.5x plus 0.5. Look at that. I was kind of on the money, right? Beautiful. Come down, share that point, take off. I'm probably not even sharing it. Whoops. There you go. Now you're seeing it. There's the square root of x. Here's our 0.11. Come down, share this point, and take off. Now you see it. Cool. Okay. That's funny. What else do I need to show? Let me go back to. Okay. So just to put it out there, let's just say we have the graph of just some random function. Some random squiggly line, right? Okay. So what we've been doing today is finding the slope at one given point, right? Well, let's say we have 2 points. Let's say I have a point here, and I have a point there, right? Well, we know this. We know the line through one point is called the tangent line, right? So if I have a line going through 1 point, that's considered the tangent line. But if I have a line going through 2 points, this is considered the secant line, right? This is considered the secant line. And the secant line, you can still find using the difference quotient formula, right? The limit of it. Because if we labeled everything, this would be x, and this would be x plus h, right? This would be x plus h. So if you need to find a secant line, well, if you're given 2 points, what can you find between 2 points? You can find slope between 2 points, right? So if I said m secant, it would be given as f of x plus h, right? The y value, so this is f of x plus h, minus the second y value, f of x plus of f of x, over your second x value minus your first x value. Which means, look at this. What do we have again? We have f of x plus h minus f of x over h. So what we can say here is that you can use the same formula to find the slope of the secant line that you can also use to find the slope of the tangent line. The only difference is tangent goes through 1 point, secant goes through 2 points. So what we're saying here is that the distance from x to x plus h is represented as h. H represents that distance. So I wish I had like a whiteboard, I could show it moving, but we can say that, so if we have x and an actual x plus h, you can find the secant line. But let's say that our h value, let's say that our h value is approaching 0, meaning that our distance of h from one point to the other is approaching 0. So we're saying that h is starting to approach 0, meaning our distance is approaching 0. And if our distance is approaching 0, that's where the tangent line comes in. So the tangent line says the limit as your distance of h from one point to the other approaches 0 becomes f of x plus h minus f of x over h. Because no longer are you finding the distance between 2 points, you are finding the distance at 1 point. So as our distance slowly gets back to that first x value, this means we're only finding the slope at one single point. And at that single point, we can find the tangent line. And that's it. I think I just wanted to get that out of the way. Just notice some similarities between those two. Okay, and that is it for 2.1 and 2.2. Excellent.